State the domain of the rational expression x plus 2 divided by x squared minus 4. The domain, you'll recall, of a mathematical something, in this case an expression, the domain is just all the values I'm allowed to use. Um, so sometimes, say with a word problem, there are some values I can't use due to the context of the problem. So if I'm doing a word problem that deals with, say, length, I don't want to use negative lengths. Those aren't defined. Or if I'm doing a word problem that involves, say, the temperature of water, I don't want to use temperature values of water that would give me things that aren't water, that is, things like steam or ice. I want to stay in the range of temperature values that give me the behavior I'm after. Um, Without a word problem, just with an expression, we don't have all those extra considerations. We're just interested in what sort of mathematical uh, restrictions do we have that might limit the domain, that might limit what x values, in this case, I'm allowed to plug in. So I'm going to look at this problem and I'm going to ask myself, out of all these operations I'm doing, um, is there any times when I can't do them? Right? And so I look at this and I say, in the numerator I have x plus 2, and I say no matter what x value I do use, I can always add 2 to it. That's always defined. I'm allowed to do that. Um, in the denominator I have this x squared. I can always square a number. That's fine. I can do that. Once I've done that, I can always subtract 4. That's fine. We can do that. So far, it looks like all x values are okay until we look at what happens next. We'd have to take x plus 2 and divide that by this x squared minus 4. Right? I can do this computation in the numerator. I can do this computation in the denominator. And then once I have some numbers, I can divide most of the time. Right? There's one time when I can't divide, or um, one class of times when I can't divide, and that is when this denominator equals 0. Right? If this denominator equals 0, then we have a problem. So I have to make sure the denominator is not 0. As long as the denominator is not 0, I can compute something in the numerator, I can compute something in the denominator, and then once I've computed those two numbers, I can go ahead and divide them, and I get a number out. So my domain is going to be everything where this happens, where x squared minus 4 is not 0. Whenever that happens, I can do all these computations. I get a number out. So I'm going to answer this domain question by answering the opposite question: what values are not in the domain? So I'd like to find out when x squared minus 4 equals 0. Those are all the x values that I'm going to throw out of the domain. I'm going to keep every x value except for the ones that solve this equation, because those are the times when I don't have this x squared minus 4 is not equal to 0. Right. So to solve this, I need to factor the left-hand side. It's a difference of squares, so it factors very easily, x plus 2 and x minus 2. So I know that either x plus 2 has to equal 0 or x minus 2 equals 0 if this x squared minus 4 equals 0. So I look at this first bit, I subtract 2 from both sides, and I find out that when x equals minus 2, I have a 0. The second bit, I add 2 to both sides. I find out that when x equals 2, I have a 0. So these are the two spots that are problem spots. Those are the two spots where my denominator equals 0 and where I would not be able to divide. So these are the two spots I have to throw out of my domain. So we can write down an answer. We can write our answer in a lot of different forms. One thing we could do is just say something like all real numbers except for x equals 2 and x equals minus 2, and that's one way we can write down the domain. Another thing we could do is we could maybe write this in interval notation. You could write negative infinity up to negative 2, unioned with negative 2 up to 2, unioned with 2 up to infinity. We're taking essentially negative infinity up to infinity, and we're getting rid of the points negative 2 and 2, just like we did here, all the real numbers except for 2 and minus 2. There are some other ways that you could try and write down this domain. Ultimately, though, you just need to tell us, get rid of 2, get rid of minus 2. Everything else is included in the domain.